Hi everyone, welcome to lesson 6 of my Surpac tutorial series. And in today's lesson, we are going to learn how to create geological digital terrain models, that is DTMs. In today's lesson, we are going to learn how to create DTMs for the radars of the lithologies, that is the weathering profile. We will also learn how to create the topography for the area from the drill hole colors, a situation where you don't have your topo file for the area. Time permitting, we will learn how to truncate the ore model by using the topo so that the ore becomes located beneath the topo, which actually seems realistic. Before I proceed, I would want to talk about the string number which stored the bifurcation points, that is this zone. Alright, I will hide my drill holes quickly, display, hide all drill holes. Then I'll display the strings for the ore model and I'll hide the surface. If you would remember, we created our ore model from string 1, but we have here another string, this yellow string. This is actually the string 32,000 which stored the bifurcation points. Remember, the presence of this string is serving as a link between the parent segment and the children segment when we were using the bifurcation union. So if you open your DTM file and you're seeing these additional strings, it is as a result of the bifurcation function that we used. Alright, again, I also stated that different geologists have different perspectives or different geological interpretations altogether. As a matter of fact, I decided to come up with two different models to validate that statement. I came up with this model and I edited the strings and came up with this all domain 1 string. If I should display the drill holes, you realize that both models are from the same drill hole data. Okay. If I should hide the drill holes, if I should hide the model, you realize that the smaller one lies within the big one. Alright, so that was just by the way. What we are going to do in today's lesson is to create DTMs which will represent surfaces of the weathering profiles. Just a brief tips about redox. We have redox in geology, we have redox in chemistry. The redox in geology simply refers to reduction and oxidation, similar to that in chemistry. But with reference to geology, a rock is said to have undergone oxidation if the rock comes into contact with oxygen. It therefore gives it a rusty nature. That is, we say the rock has become oxidized. In reduction, oxygen leaves the rock. That is, the rock becomes reduced. That is, it becomes deprived of oxygen. Alright, that was just a pretty basic set of information. Let's dive into Surpac and see what we can do. I will go to my database in the status area, display drill holes. This time I'm going to display from the geology table, and the field we are going to look at is the redox. No constraint, apply. Good. These colors you are seeing here is as a result of the styles we apply to the drill holes. Let's recap that quickly. Display, drill hole display styles. I'll click on that, geology, redox. The cox here refers to completely oxidized zone and the color is red as you are seeing in graphics. The fresh here is color blue, indicated at the base of each drill hole, and the strong here, strongly oxidized, referring to the transition, is color yellow. Alright, so what we are going to do is to create a DTM surface that will represent the base of the oxidation, the base of the transition. By so doing, we are trying to demarcate the area into 3 zones: oxide zone, transition zone, and the fresh zone. So we will do that quickly. We will have to first section our drill holes. We will go by our previous way of sectioning, which is the graphical method, because this is an oblique type of drilling. We wouldn't go for the northern section method. Alright, so I'll click apply. Here, you need to be very cautious when you are clicking and dragging to define a cutting plane. Otherwise, when you finish cutting, you realize that a portion of the drill hole as well as the colors have gone missing. So be very careful when you are going about it. Okay, so I'll click and drag to define a cutting plane passing through the drill hole colors. So this will be my first section. Alright, so I will create a string here which will demarcate the base of the oxide, likewise the transition. I can do for the oxide and come back later to do for the transition, but that wouldn't save me much time. I will do them simultaneously henceforth. I will use a string color of red to demarcate this, and I'll use a string 6 which is color yellow to do that. I can come here and change the string number. String 1 is always Surpac's default. I can change it over here. Again, I can go to this icon which says enter or change digitizer point attributes. I'll click on that, and within this box I can change the string number. The Z field here, the elevation is inactive. The description field here, you can enter anything to suit your preference. When this is checked, use description of selected points. As you digitize a point in graphics, it has its own default description fields. When you check this box and you enter a description field here, whatever point you digitize in graphics will have that point attributes or description. Alright, project selections to the current plane. When you check this box, any point you digitize in graphics will be picked up by Surpac to snap to the plane. Remember, a section defines a cutting plane. Alright, so I will change this to 8. Enter. Then I will go here which says create points using the mouse. I'll click on that. Alright, but before we go on, remember this is an entirely a whole project that we are going to do, so we'd want to do everything on a new layer. Go straight into your layers pane, click on new. Then I will enter, let's say Redux, apply. Alright, then we've already changed the string number. As you can see here, it has been changed to 8. So I will click on this digitize a point using the mouse. I will start digitizing the base of the oxide. Then I will go back to change the string number to 6, apply. Then I'll digitize the base of the transition. Okay, when I'm done, I'll close my section. Then I'll zoom to data extent. Then I'll go to section the next couple of drill holes. The same procedure. You right click to select previous numbers that you have entered, 8, apply. Then I'll click on this to create points. Let me move this point up a little bit. Okay. Then I'll go back, change this one to 6, apply. Then I'll click on this to create points. Close my section, zoom to data extent. Then I'll come to the next drill hole, section, apply. As you can see, the blue column of the drill hole is missing because I didn't cut it properly. I'll go back and I'll section again. Okay, it's now here. And I'll go by the same procedure, change the digitizer string attributes to 8, click on this to create new point. Six, apply, create points, escape, close section, zoom to data extent. Then I'll go to the next one. Okay, as you can see from these drill holes, because the hole was not all that logged properly, you're having an oxide zone below a transition, which actually doesn't seem realistic. I will choose to box them up as the transition. Okay. Then I'll change the digitizer string attribute to 6. Create points. Even though this is a repetitive process, you need to love what you are doing to be able to come up with something meaningful. Someone may ask, why are we digitizing these zones in the first place? The reason why we are doing this is that after creating the strings, we will create a DTM out of it, and that DTM will be used to constrain our block model that will be created in the subsequent lessons to come. With the help of the DTM created, you will be able to have a fair idea about the thickness of the overbed, and that is the oxide zone. Likewise, the transition zone. We are only trying to come up with a surface representing the base of the oxide, transition, and the fresh, so that we have 3 zones: oxide, transition, and fresh zones. You see, we don't have any transition here, but I will choose to digitize the transition for this hole too. Okay, so I'll do that. 8, apply, create points. Change the number to 6, apply, digitize. Remember, this is based on my geological interpretation, as you may also have yours. We are close to completing the task. Let's speed up a little bit. Close section, zoom to data extent. We are left with 2 more sections to go. I'll change this one to 6, apply, then I'll click on this to create new points. Remember, the length of the strings do not necessarily have to be the same. You are just trying to come up with strings representing the base of the oxide and the transitions. Okay, so we are left with the last one. Okay, we didn't section well, that's why we are not seeing the portion of the drill hole. I'll close the section, go back and repeat it. Okay, so here we are. I'll do that quickly. Digitizer string attributes 8, create points, escape, go back, change the number 6, apply, create points. Okay, so we are done. Now I'll close my section. So here we are. Okay, so what I'm going to do is to save the strings separately as we have digitized. I will go to save, click on it, and I'll enter a name, let's say base of oxidation, so base underscore oxide, and I will enter the string range number here. I will give it 8 so that Surpac will save string 8 as part of the redos file. Okay, so string 8, save, apply. Then I'll go back to save, change the name to base of transition, and I will enter string range of 6 so that Surpac will save the string 6, which is the yellow string, separately, apply. Alright, so if I should delete the redos layer and go into my work directory, I will see my base of oxide string, base of transition string. Let me bring the oxide string here. Okay, good. As you can see, if we should go ahead and create a DTM from the string file, our DTM will end directly on the drill holes. Let's do that and verify. Object 8, so that it will take the string color as the one in graphics, which is red. You don't have to check the box for the break line test. Break line strings refer to strings which have points or segments overlapping each other, so you uncheck this, apply. So you see the DTM is lying exactly at the couple of drill holes that are at the ends. We don't want that, so we will use the previous function that will add to us a new segment to create additional segments. So I will go to solids, triangulate, extrude and triangulate, and I'll click on this segment, and I'll enter an object ID of 8 to take the same color as the string 8 that was used to digitize the base of the oxide, with all other parameters remaining constant. Remember, we have covered this area in the previous lesson. Apply. Okay, then I'll touch this one too. Additional segments have been created. You can choose to delete them or you can choose to leave them. You are going to form a DTM out of it, so it wouldn't have a significant effect on the DTM you are going to create. So I will delete the trisolation. Go to solids, edit, trisolation, delete. Then I will touch my trisolation. Okay, beautiful. Then I will have to save my string file because it has been edited. I'll go to save, base of oxide string, I will overwrite it. Okay, then I'll delete the oxide layer and bring my transition so that I'll do the same for the transition. This is interesting. I'll go to solids, triangulate, extrude and triangulate. Then I'll touch this. The same, this time around, I will change the object ID to 6. Apply. Then I'll click on this. Additional segments will be created, but we do not need the trisolation, so I'll go to solids, edit trisolation, delete. Okay. Deleting the additional segments is in accordance with your preference. I would want to keep them. Nothing will happen to it. Okay, so I will save my string. I will overwrite it. Okay, beautiful. Now I will create a DTM from the string file. Go to surfaces, create DTM from layer. Then I'll give it an object ID 6, the same string number as used in graphics. Apply. You see, the DTM surface is going beyond the drill holes now. I will save my DTM file. The file extension, notice that it has changed here to .dtm. Apply. Okay, I'll delete the layer and create for the oxide. Surfaces, create DTM from layer, an object ID of 8 to take the same color as the string used to demarcate the oxide zone. Then I'll save it. Okay, so if I should delete the layer and bring back my files, my DTM files, now we have the base of completely oxidized DTM and we have the base of the transition here. I'll drag them into graphics. I brought the string file. Let me bring the DTM. Okay, so this is it. We have divided the area into 3 zones: the oxide, which is the area here, and the transition, which is between the 2 DTM surfaces, and the fresh, which is the blue area. Okay, we will use this to constrain our block model when we get to that section. Alright, so I will delete the layers. The next thing that we are going to do is to create a topography of the area. You know, the surveyors or the geomatic engineers are the best people to confront when it comes to getting a topo for your area. In a case where you do not have it, you can generate it using the drill hole colors. So we will do that quickly. We will go to database and select extract, scroll down, come here and select drill hole layout, click on it. What this function means is that it is going to create a string file based on the colors of the drill holes. That is, a point will be generated for each drill hole and it will be linked up to create a string file. Then we will form a DTM out of it. Here you will enter the file name, let's say topography. When you enter an object number here, it will be added to the file name. We do not want to do that, so you leave the field blank. Now here, the description fields. When I click on this, we have so many description fields, but when the file is created, remember the string file is going to be created from the drill holes. So they will have description fields similar to the drill holes. We have the hole ID, the azimuth, the dip. After this file is created, we will open it and see the description fields. The first description field, D1, will take the hole ID. D2, the second description field, will take the maximum depth. D3, the third description field, will take the azimuth, and D4, the fourth description field, will take the dip of the drill hole. So notice that. Okay, so I'll click apply. No constraints, apply. The file will be saved and it will appear in the message window. Excellent. I'll go into my work directory and this is my topo string. You see, it has created a string file using the drill hole colors. Now let me open the file so that we see what we have in there. Drill hole layout, that was the function we used, and the file is topography. Here, this is the header. Here represent the axis. If you should cut it with an axis line, usually represented as 0. We have the string numbers here. We have the coordinates y, x, and z. This is the hole ID. The first description field is the hole ID. The second description field, this value, is the maximum depth. The third description field, D3, is the azimuth of the hole, and this value is the dip. That is why you have negatives attached to it, because it's a depression angle. Okay, so what we are going to do is to create a DTM for the topo. But remember, when we create it, when we create the DTM surface, it will cover only the drill hole colors, and we do not want to do that. If I should go to surfaces, create DTM from layer, topo.string, you can see that it is only covering the drill hole layout. It doesn't seem realistic when it gets into the field. We would want to extend it so that it goes beyond it. Okay, so I will want to create or extend the segment or the string so that it goes beyond the drill holes. So I'll do that quickly. I will go to the same solids, triangulate, extrude and triangulate a segment. Then I'll click on this. Then the object ID, I can enter one or anything, apply. And you see it has created additional strings. I can delete the tri-isolation, escape, go back. I want to repeat the procedure. Then I will touch my string, apply, and it will create another string. And I will delete the tri-isolation. Okay, and I will save my string. Then I will delete the layer, go back and bring my topo file. See, it's now covering the drill holes. Then I'll create a DTM from it. Surfaces, create DTM from layer. Object ID 1, uncheck break line test. Perfect. Now you can see that the topo is going, it covers the entire drill holes. Now, as you can see, these edges of the topo is not covering the drill hole, so we want to create a portion of the topo here and here. So I will just digitize any area. The topography is still the active layer. Good. I have not saved the DTM for the topo. Okay, so I will digitize any line here. Escape. Then I'll do the same thing here. Start new segment. Escape. Okay, as you can see, if I rotate in graphics, we have these two strings, the string 6, which is yellow here. I would want to add it. I can renumber the segment anyways. I can go to renumber string here, click on it, then I'll select this to 1 so that it will take the same string number as the topography. Okay, then we have to lift the string to come to the same elevation as the topo, and we will do the same for this one. We do not know what elevation that we have to bring these segments, so we will inquire a property of a point on the topo. Go to inquire point properties, then I'll click a point on this string of the topo, and as you can see, we have the values in the message window. We have the elevation 157.172. so this is what elevation we are going to apply to this segment so that it will come to the same elevation, and we will join it with the tri-isolation. Okay, you can do this by clicking on this icon here, which is perform math on all points of the selected segment. Again, you can go to edit segment maths, click on it. Then the field that we want to edit is the elevation, so you select Z value. Then the expression, the value is 157.172. You can copy it and come and paste it right here. Okay, and you click apply. Then it says in the status area, select the segment to apply mass. You click on this segment, and Surpac will bring it right at the elevation. You see, so we can now join this to this with an with a DTM. We repeat the procedure for this string or segment, but we will have to inquire a point here first so that we will lift it. Remember, different points have different elevations on the topography, so we will go to inquire point properties, and I'll click on this to determine the Z value. This time is 182.252. Okay, so I will go to, I can right click anywhere to select recent commands that I have used so far and go to maths. Or again, we can go back and select edit segment maths. Then we select the elevation, which is the Z. Then we select the expression. We can copy it, come and paste it here, apply. Then we will select the segment to apply that operation. I'll click on this and it will be lifted to that elevation. Okay. Alright, so what I'm going to do is to create a DTM for that. I can edit or move the point. Okay, so I can create a, I can save the string file now. Alright, then I'll create a DTM for the string. Now we have the string here. I don't need the DTM, so I'll delete it. Exit graphics, I'll bring back my string, and we have the two segments added to it. Now I'll go to surfaces, create DTM from layer, object ID of 1. Then we have it here. Now I can save my DTM. Okay, excellent. Now exit graphics, bring back my DTM, display my drill holes by any table, no constraint, apply. And you can see that the drill hole colors are located right on the topo, as you can see here. Let me bring my all domain 1 DTM. Okay, let me bring the domain 1. Okay, as you can see, the all model is penetrating the topo because when we were digitizing, we sectioned the drill holes, and based on the assays, we digitized mineralization zones. When we were digitizing, we went above the colors of the drill hole. That is why you are seeing the ore penetrating the topo. We can truncate it so that the ore becomes, or it stays beneath the topo, which actually will represent what is it in reality. Okay, we will do that in the previous lesson. So this is, you have it. Let me bring the DTMs for the oxide and the transition, and you see how it looks like. Okay, so this is it. We have the DTM for the oxide and the DTM for the transition, as well as the topo. Alright, so in the next lesson we are going to truncate the ore using the topo. Thanks for watching, and catch you later another time. Bye for now.